Right. So we have seen the MPLS use case. Now, not only this much, MPLS can do much better along with BGP. Along with BGP, that's important. Along with BGP, what it can provide. Along with BGP, MPLS can have another control plane for virtual connection. Right now, we saw one control plane. Based on labels, the packets were controlled, forwarded. It was based on the label, isn't it? That's one control plane. MPLS control plane. Using labels. Sir, did you check those commands? MPLS LDP binding command. I asked you to check. Okay. Okay, I got you. Yes, yes. I do hear you. Yes, that's nice. So you see that is one control plane. Controls the packet flow using labels. Now MPLS can also do layer 3 VPN using labels along with BGP. So using BGP's attribute called extended community, we can exchange labels for the tunnel. See, right now, between two routers, labels are exchanged. Now, what is tunnel? We got many routers between which we are going to have a connection circuit. You see, we have almost 8 routers, and let's say this is the service provider network, and this is service provider router 1, this is service provider router 8. After this, customer is connected. Here also customer is connected. This is customer's network. Now you want to provide a connection for the customer. You would like to provide a tunnel so that the customer's router, both the rose in French, rouge means red. Okay, let me draw rouge. Both this rouge can talk through the tunnel. What is the benefit? Benefit is you will not be exposed to the provider's network. Customer will feel that they have a dedicated wire. Sorry, your voice is breaking. Did you say something? Come again, sir. Yes, yes, tell me, sir. Yes, correct. So for this, what is needed? You need a control plane. Let me explain you that. You see, you do not want to see any of this router. In reality, there are 8 routers, but according to the customer, they feel that they are connected to S1, and S1 is connected to S8, and S8 is connected to the remote office. How is this possible? We know that using IBGP, these two can form neighbor because BGP is a TCP protocol. If there is IP path, they both can form neighbor. Likewise, we have an address family called VPN v4 in BGP. Using that layer 3 tunnel VPN v4, I told you already we have routers, we have reachability. S1 can form neighbor with the S8, which means what? They have reachability, no IP path, I said. Isn't it? So, same like you have IBGP between R1 and R8 using the IP path. This VPN v4 can also be established between S1 and S8. The VPN v4 is inside BGP. So when you enable VPN v4, extended community gets enabled and labels are carried and a separate routing table for this VPN is established, is created. See, you already have a routing table. You just now said you have OSPF. Let me draw that in the blue color. You already have one routing table in this router. Now for the customer, you got ROJ routing table. So whatever the customer advertises, it goes only to this routing table and goes through the tunnel and delivers in this routing table and goes to this. So you got two control planes, one for the VPN, which takes the customer's traffic, which is the customer's circuit. The other one is hop by hop between these 8 routers. That's another control plane. So you got two routing tables now. One for the ISP to provide reachability, because as you said just now, without reachability, you cannot have IBGP, you cannot have BGP VPN v4. So you need OSPF, you need routing table, you need reachability. But customer needs separate routing table. According to the customer, S1 is connected to S8, not S2, S3, S4, which means they need a separate routing table which will show next hop as router 8. And in router 8, it will show next hop as router 1. So when you create VPN, what actually happens is there's a separate routing table, this red color one gets created for the customer. All the customer routes enters this routing table. Whatever enters into this routing table will go through the VPN, go to router 8's red routing table and goes to the customer. And locally for reachability, you have blue routing table. That is the default routing table. So MPLS layer 3 VPN means we providing a separate circuit called layer 3 circuit or layer 3 VPN using BGP extended community. Now there will be separate routing table because we do not want customer route and the provider routes getting mixed. That's one reason. Another reason, as I told you, a router should see S1 should see S8 as the next hop. None of the other routers should be seen as the next hop for VPN, for which you need a separate routing table because the default routing table shows S2 as the next hop and S2 in S2 S3 as the next hop. Yes, likewise, you have one routing table. You don't want that routing table for the customer routes. For the customer routes, you want VPN service. So what exactly happens is, like what you saw in the previous class, you will have one MPLS that is for switching between every router physical hops. We call it as transport label. We call it as transport label. The transport label is for hopping between physical routers. Now you will have another MPLS. This is for VPN. So you remember I was telling you that bottom of a stack bit will be on for the top layer, will be off for bottom layer. You remember that out of 32 bit you have one bit for bottom of a stack. When you have more than one layers of MPLS, you see you will have this bit on. You know, when the packet goes here, it is this label that will be used. Let's say label 20. And then only this label will be swapped with label 30. But there will be another label here for VPN for the customer network, let's say 88. That will never change. When it goes to this router, only this top label will be popped off and this label will go here. This understands that it's for the VPN and delivers to the VPN routing table. And there, this is popped off and sent to the customer. So what two MPLS layers, and each layer will have their own labels. The top layer of MPLS is transport layer. That's for every hop, physical hop. And the bottom layer of MPLS is service layer. Service layer or service label will be there. Service label will be there at the bottom, and the transport layer will be there at the top. Service layer label will get popped off only on the final router, but the top label, the PHP, will happen on one router before the final, which we learned yesterday. You got it, sir? We call this as MPLS layer 3 VPN. Without MPLS and BGP, this is not possible. You always need BGP. So what you have learned till yesterday is the pure MPLS. What we are learning now is the advanced level MPLS with BGP. Yes. So we will be learning this in detail now. MPLS layer 3. Lab, it's too early for you. If I do now, you won't be comfortable. If I do now, you won't be comfortable. I'm trying to give you a clear picture of the working so that when I do lab, when I teach you configuration, you will know why I'm configuring those commands, right? So far you should have this understanding. What is that? I need MPLS, like what we did in the previous class. Secondly, I need BGP. Between S1 and S8, I should form IBGP. There should be peering. And then I should enable MPLS layer 3 VPN called address family VPN v4 in BGP. Address family VPN v4. It is needed. Repeating again. For S1 to negotiate S8, you need reachability, isn't it? What is MPLS? Sir, what is MPLS? Label? Label? What is the last word? Label? Label switching. Then why you are talking about replacing MPLS with OSPF with MPLS? Not possible. MPLS is not a routing protocol. MPLS needs OSPF. First of all, S1 and S2 will not form neighbor if you don't have OSPF. You know that? The loopback should be reachable. MPLS itself won't come in between S1 and S2 if S1's loopback is not pingable from S2. You must need OSPF. OSPF provides route. MPLS cannot provide routes. MPLS can only use those routes which are already there and provide label. So to provide route, you need routing protocol. You need routing protocol to provide routes. Okay, so MPLS is multi-protocol label switching only, just the switching. All right. So now when we don't have BGP, this layer 3 VPN is not possible. When you don't have MPLS, this layer 3 VPN is not possible. So you have to run MPLS on every router. You should have OSPF. So whatever you did in the previous lab, you have to do it first. On top of that, to bring the VPN up, you need to have BGP. And using BGP, you are going to negotiate a tunnel between S1 and S8 and connect the tunnel to a separate control plane, separate routing table. For that, you need to create a routing table. How to create a routing table? You will create VRF. VRF stands for Virtual Routing and Forwarding. Virtual Routing and Forwarding. Meaning virtual routing table, that's all. You're going to create additional routing table other than the default. By default, you have a lot of routes in the default routing table. But you don't want to mix those routes with a customer route. In order to create separate routing table and attach it to VPN, you need to have VRF, virtual routing and forwarding. This virtual routing and forwarding can easily mingle with BGP, layer 3, MPLS, VPN, right? So let me write down the steps that you are going to do in the lab. First, as usual, you need to have IGP protocol. Recommended is link state protocol. Okay, use OSPF. Number 2, enable MPLS on all the routers and all the interface in the path. Trace and see whether the labels are used properly. After verifying them, that is what we did up to yesterday class. After this, you are going to form IBGP between the provider edge router. Which is the provider edge? S1 and S8 are provider edge. Is it not an edge router? Is this not an edge router S1 or S8? It is. Yeah, it's connected to the customer. That's the provider. So you need to have an IBGP between provider edges. Piece. Next, after this, we have to create a VPN tunnel. Means we need to use something called address family VPN v4 under BGP to negotiate VPN. To negotiate VPN, we need address family VPN v4. Next, after VPN v4, we need to create VRF. Under VRF, we need to specify route distinguisher and route target. Those are all the values that will be used to identify customer route. See, you may be having many customers on the same provider edge trying to use the same VPN, S8 and S1. You may be connecting many customers to S1. Now, how do you know this is the route from customer A and that is the route from customer B? To differentiate, you have route distinguisher. And to say to which remote, right? Now, you see, you have a provider edge router connecting to a customer called Orange, connecting to another customer called main one. There is another customer called Airtel. There is another customer called whatever. Okay, French X. Now, you are also another ISP who is taking route from connecting all these customers. See, they're also customer for you. You are the ISPs of ISP. Now, you have only one VPN which you just created, but how many customers route you need to use to go through the VPN? 4 customers. So for 4 customers, you will have 4 separate routing table. So you will create 4 separate VRF. In each VRF, to differentiate the customer, you will have different number called route distinguisher. Now, to send the red to the remote red, you need route target. See, remote means what? Target. So route targets to identify the remote routing table and deliver the route. Route distribution to locally differentiate Orange from Mona, Mona from Airtel, Airtel from French X. Mona is one of the ISP. Orange is another ISP. Airtel is another ISP. French X is another ISP. And this provider edge is another ISP. So there are 5 ISPs involved, but these 4 ISPs are supported by that one ISP, which we are working now. Okay, anyway, let's not go too deep into this. We'll go step by step. For this, whatever you did yesterday, along with that, you need to go and enable IBGP between S1 and S8. After that only we will start learning these things. Okay. First of all, you need to have BGP between this. So if you have the lab ready, you can share the screen and you can do now. Please go to privilege mode. Okay. Now type show IPBGP. Show no, don't do anything. Show remove IP. Show BGP. VPN v4 unicast all summary. See, nothing is there because so far VPN is not configured. Let us configure now. Go to BGP again. Okay, now say address family IPv4. Sorry, VPN v4. Remove the IPv4. VPN v4 unicast. Enter. Neighbor 5.5.5.5. Activate. You are activating the VPN. Right. Now go to router 5 and do the same. Okay. Now you will see VPN. Go back and check that same command which I was asking you to do. VPN v4 command. Your VPN is up. Now we will continue this in our next class.